All right, the next section that we're going to look at is on divisibility rules. These are some methods that we can use to determine whether a number is divisible by the numbers 1 to 10. We won't do much with 7, actually. That's the only one that doesn't really have much of a rule. But we're going to look at most of those numbers, okay, to see if they're factors. So let's go through them one at a time, and then we'll do some examples after the fact. So divisible by 1. This is pretty straightforward. As long as that number is a whole number, that means it does not have any decimals in it, in between digits. As long as it's a whole number, then it's divisible by 1. Okay. Divisible by 2. If the number ends in an even number, or it is an even number, okay, then it's divisible by 2. So 2 is a factor. So that means 2, it ends in a 2, 4, 6, 8, or a 0. If it ends in any of those numbers, then it is divisible by 2. Okay. Divisible by 3. This one's pretty cool. I like this. This is a really slick rule to use. And it doesn't matter how big that number is, you can figure out if it's divisible by 3 quite easily. Okay, so this is how you do it. You add up the digits of the number. So you add up the individual digits in the number. And then you look at the sum. And if that sum is divisible by 3, then 3 is a factor. So take a look here. We've got 68. So the individual digits, that's 6 plus 8, and that equals 14. Okay, and then you look at just 14 and you go, okay, let's 3 go into 14. You use your skip counting. 3, 6, 9, 12, 15. Oh, we didn't land on 14, so that means 3 is not a factor. Okay, look at this next one. 429. So we go 4 plus 2 plus 9. That gives us 15. So skip counting again. 3, 6, 9, 12, 15. 3 goes into 15 evenly. So it is 3 is a factor in that number. So it's a factor. Okay. Now 4. 4 is quite interesting. Once again, it does not matter how big this number is. It could be in the bazillions. It doesn't matter because look at, you only look at the last 2 digits and you see if they are divisible by 4. So look at this first number right here. Whoops. Oh, shoot. Look at this number right here. 5,068, right? The only 2 digits we look at or consider are these ones right here. Okay. Again, 9,374. Doesn't matter how big it is. This is the only part of that number that we look at. And then we look at how well 4 goes into 74, or how well 4 goes into 68. Okay. And I'm going to show you some strategies on how to break that down afterwards, but I'm going to get through some of the rules here first. Okay, divisible by 5. This one's, again, another easy one. It ends in either a 5 or a 0. Okay, if it ends in a 5 or a 0, then it's divisible by 5. Divisible by 6. Again, this one is so easy, very, very easy. Okay, so if the number is, let's just cut to the end here. If it's divisible by 2 and 3, then it's divisible by 6. Let's say it's only divisible by 2, but not 3, then it won't be divisible by 6. If it's divisible by 3 and not 2, again, it cannot be divisible by 6 either. Okay. All right. Moving right along. So divisible by 8. So just like with the 4, we only look at a few of the digits. Same with this one. So for this number here, 6,248, we will only look at the last 3 digits. Okay. This one here. So again, you could have a number in the bazillions again, and really the only numbers you look at are the last 3 digits. That's it. Okay. Coincidentally, if you look, for 2, 4, 6, 8, actually, and 10, I guess, like they have to be even numbers, right? So if you look at a number, you're trying to find out if it's divisible by 8. If it's not an even number, you don't even have to check, right? If it's not an even number, then it's not divisible by 8. Same with the 6s, same with the 2s, same with 10s, I guess. Okay, so again, I'm going to show you how to do the 8s. We'll do a few questions like that in a sec, but I want to show you the rest of the rules first. So let's look at 9. 9 is very similar to how 3 works. Okay, so for number 9, you're going to add up the digits of the number, just like you did with the 3s. And that sum, you look to see if that sum is divisible by 9. And if it is, the 9 is a factor. So once again, for the number 627, we're going to add 6 and 2 and 7. That gives you 15. Does 9 go into 15? Well, we try our skip counting, right? 9, 18. Oh, we already passed it, right? So it didn't land on 15, so it is not a factor. Look at this one here. We got 4,563. So we're going to add 4 plus 5 plus 6 plus 3. That gives us 18. Does 9 go evenly into 18? 9, 18, you betcha. So it is a factor. Okay, so we're good there. The last one, divisible by 10, pretty slick, ends in a 0. So nothing too tricky there. Now, we're going to throw a number up here. Actually, let's use some of the numbers that were in our example up here. Let's start 5,068. We're going to do that one. 5,068. Now, I just want to show you how we do 4s, right? So you remember with 4s, what is the rule for 4? How do we know if 4 is a factor? That's right. We look at the last 2 digits of that number, okay? So this is how I would do it. I go 68, and I actually try to shave that down. You can use long division if you want. You can use skip counting if you want. This is just a method that I use. If you don't like it, just ignore it. I pick big numbers that are multiples of, in this case, 4 that I know of. I know that 4 goes into 40. So I'm just going to subtract 40 from this to make the number that I'm looking at smaller. Okay, so if I subtract that, I get 28. Okay, a number that I know 4 goes into that's close to that is 24. So I'm going to subtract 24 and see where that puts me. And I have 4 left over. Does 4 go into 4? You betcha. So that means that 4 is a factor of 5,068. Okay. Let me show you another example. Again, I'm just going to use the examples here. So we had 9,374. Okay, so let's look at that one. 9,734. I think that was it. No, it was 3,074. That's what it was. 9,374. Okay. Man, I'm old, man. Okay, so we look at our last 2 digits to see if 4 will divide in. Okay, so again, 74. Again, I'm going to subtract some numbers that I know are multiples of 40, or sorry, of 4. So I'm going to subtract 40 from that. Gives me a smaller number, right? So that gives me 34. Let's see. I know that 4 goes into 28. I'm going to subtract 28. And if you have to do it in smaller chunks, that's fine, right? So that gives me 6 in the end. Does 4 go evenly into 6? No, it doesn't. So that means 4 does not go evenly into 9,374. Okay. Now again, like I said, if you wanted to do it the long way, 4 into 9,374, you want to do long division, go ahead, as long as you're not using your calculator. Okay, now I'm going to show you, actually I'll erase all these. I'm going to show you 8s now. It's the same idea, except it's just bigger. So let's look at our 8s, 6248. 6248. So what's the rule with 8s? That's right. We look at the last 3 digits of that number, right? So 248. Here you have to know your facts. You have to know your multiplication division facts for this to make a lot of sense to you. I always just look at the first two digits. It's 24. I know 8 goes into 24. It goes in 3 times. So I'm going to subtract a bigger chunk, though. I'm going to subtract, instead of 24, I'm going to subtract 240. Just add a 0. You can do that. Okay? And that will leave me with just 8. Does 8 go into 8? You betcha. Okay? So 8 is a factor there. That was an easy one. Let's look at this other one. 54, 58. Let's look at 5,458. Once again, with 8s, we're only looking at those last few digits, 3 digits, and we're going to break it down, right? So 458. Woo-wee, that's a good one. Okay. So 8. Hey, I know 8 goes into 40. I know 8 goes into 45 times. So, but instead of subtracting 40, I'm going to subtract 400. That leaves me with 58. I know my facts really well. So when I look at the number 58, I go, hey, 7 times 8 is 56. So I know 8 goes into 56. So I'm going to subtract 56. That leaves me with 2. Does 8 go into 2? No, it does not. So 8 is not a factor of 5,458.